Now let us compare between the torsional rigidity or torsional couple permitting the twist for a solid and a hollow cylinder of equal mass. Suppose let C and C dash be the torsional rigidity, or you can say torsional couple permanent angular twist of say cylindrical rod of same mass m and density rho with same length L. Only difference is that the C is for C cylinder is solid of radius r, and for C dash cylinder is hollow of inner radius r1 and outer radius r2, such that r2 is greater than r1. Fine. So now what we will see, so the mass is given by pi r square L into rho for solid, say ms for solid cylinder. For hollow cylinder m hollow is equal to pi L rho is r2 square minus r1 square. This is the mass. So rho is same, for rho is same for both. L and rho is same for both. Now since ms is equal to mh, both masses are equal, we have considered that both masses are equal, so pi r2, this one is pi r square L rho is equal to pi L rho, which implies L rho will cut, pi will cut pi, so r square is equal to this one. Fine. Now we also know C is given by eta of pi by twice L r to the power 4. Fine. This one in the previous lesson we have seen. And C dash for hollow cylinder, it is given as eta pi by twice L r2 to the power 4 minus r1 to the power 4. Now if we take the ratio, so this is A, this is B. Fine. Now B divided by A implies C dash by C. C dash is n pi by twice L r2, this one, and this one is n pi by eta pi by twice L r to the power 4. So this and this cancels out. So what remains is r2 to the power 4 minus r1 to the power 4 divided by r to the power 4. Fine. Now what we will see, so in the what we see, c by c dash is equal to r square to the power 4 minus r1 to the power 4 divided by r to the power 4. Here we will see that from this equation, when we have compared the two mass, we have seen that r square is given by r2 square minus r1 square. So if we substitute the value of r square here, what we will get here, it is r2 to the power square minus r1 to the power square, that is r square into whole square, and this one what we can write, r2 square whole square minus r1 square whole square that is given by a square minus b square, r square square plus r1 square r2 square minus 2 square. Now as we can see, now this one will and this one cuts as a square, so c dash by c is given by r2 square plus r1 square r2 square minus r1 square. So here what we will see, since r2 square plus r1 square, this one is greater than, always greater than square minus r1 square, so this term is greater than this term. See, c dash r2 square minus r1 c2 equal to c into r2 square plus r1 square. Since this term is always greater than this term, fine, this one is greater than this one, so c dash will always be greater than c. So c dash by c should be always greater than 1, since therefore c dash is always greater than c. So as you can see, the torsional rigidity for a hollow cylinder is always greater than the solid cylinder. So there is an interesting case. Suppose if we consider two axles of same material and same mass and length, we will prefer a axle, we will prefer a hollow cylindrical axle rather than a solid one. Why? Because for the hollow cylinder, the torsional rigidity is higher than the solid one, and if you want to make the axle of a material, we need a material which high torsional rigidity. Because suppose when we suppose there is a wheel, suppose this is a wheel and it is connected by this two wheel is connected by axle. If we rotate this one in this direction, this also needs to rotate. Now the rotational kinetic energy provided here, if we want that the transfer, if you want to transfer the rotational kinetic energy here to here, kinetic energy here, so if these two should be same or the transfer is maximum, So for transfer of rotational kinetic energy to be maximum, what we need? We need that the torsional couple produced, the torsional couple produces minimum twist angle. So if we rotate this one, this cylinder should twist less. If we apply a torsional couple or a torque, then this cylinder should not twist more. As C is given by tau by theta. If theta is less, C is more for a same torque. So if this theta is less, then the kinetic energy transfer will be maximum. Otherwise, the amount of kinetic energy applied here will be used up in twisting the cylinder. And hence the transfer of kinetic energy will be less. So for better transfer of kinetic energy, or you can say better transmission of torque, better transfer of kinetic energy, we need a material of higher C. So for better transfer of rotational kinetic energy, or for better transmission of torque, we need material with large C. Now for same material of similar mass and length, torsional rigidity is more for hollow cylinder than a solid one. C dash is greater than C. That's why we prefer hollow cylinder for use in axle. So you can see hollow axles are used in the automobile axles, and also say in bicycle also. It is formed not by solid rods but by hollow rods. So this is it. So this may come that why hollow cylinder is preferred than a solid one for better transmission of torque. Then you should give this proof. You should compare the torsional rigidity for a solid and hollow, and show that C dash is greater than C. Fine. This is what comparison of